Okay, hello. Welcome to our Quickfire Max Clinic. I'll be doing this every week on Thursday, 5 to 8 p.m. So it's now 5 p.m. Today I'm also trying out the streaming on YouTube as well. So for the previous few times, I've been doing it on Facebook. Okay, so this time we are going on bigger platforms. Okay, so we wanted to continue to try out different platforms and avenues to reach out to more people. I know that this might be the first time that we are doing it on YouTube. I don't think there'll be people watching it on YouTube yet, but I try my best to record as in try my best to do as much as I can over here. Okay. So apart from, okay, we have some good news as well. Of course, over the past week, I've been trying to reach out to different types of channels and see which one works the best. Okay, and some of my friends actually told me to actually try Discord. Okay, so I also established my Discord server as well for students to actually come in to post like homework questions and whether they are looking for some help or whether is it some form of revision for content topics. Okay, so I just established my Discord server as well. Okay, so right now I'm live on Discord, on YouTube, and on Zoom. Okay, previously we have only been doing it on Facebook because I wanted to try Facebook Live, and there are more people who are who know me there lah. Okay, so right now I'm moving on to other platforms to see whether I can tap out to more students. Okay, so for those of you who are seeing this for the very first time, okay, my name is Moses, and you can call me KM or you can call me Moses. So basically, I'm a maths tutor for over 10 years. So I see that over the past few years that a lot of people are actually taking up the initiative to do more self-studying on your own. So I'm very thankful and very happy that this is happening, and I see that a lot of people are taking charge of their own studies from here onwards. So my specialization is in mathematics, so I wanted to create as much form of resources for everyone to tap onto while doing your own studies, and sometimes you guys just need an extra tip or that Eureka moment. So I created the Discord servers, I created my Telegram channels, I also created a WhatsApp group for some of my closer friends on WhatsApp to join in as well. So the WhatsApp group, I want to keep it a bit more private, but Discord channels and my Discord channels and my Zoom and my Telegram channels will be more for the open. Okay, so if you guys want to like keep in touch with me or to get daily or regular articles and insights, okay, about just generally about mathematics in general, okay, you guys will be feel free to join my Telegram channels and my Discord server. Okay, so I'll now put in the Telegram the Telegram channels onto my YouTube channel over here. Okay, I created two of them. One of them is for primary school students. One of them is for secondary school students. Okay, so I put them in the YouTube link already. So for those of you onto the Discord Telegram channels as well, these Telegram channels are also open to all of people as well. So I started off with using Telegram channels because I thought that is a more proper way to send in content articles, so on and so forth. Okay, but after that, I see that there are a lot of people using Discord and a lot of people using WhatsApp. Okay, so I open up those channels as well. So for those of you who are keen to find out more over there, you guys can also click over to those areas, those places as well. Okay, I've been told that Telegram, WhatsApp, and Discord are like the teen package. It's like a teen package. Is that true? Or maybe are there more platforms that should I explore? That of course, this must be able to let me do my do my streaming and to turn on videos and share screen with you guys. Okay, that will be more optimal lah. Okay, otherwise it'll be defeating the purpose. Okay, so right now I just entered Discord like last night, so I just established it today, and then to set up like the channels, the notes and resources, setting up the group rules and all this. It's a learning curve. But I see a lot of potential over here, and I managed to get on the whole this global server of mathematics. So it has like more than 6-figure number of people. It's like in hundred thousands of people on this Discord server, just helping out one another all over the world in mathematics. So people can just post questions there, then you'll be assigned a helper, then you all can just ask questions, interact. I think it's a very good initiative. Because I believe my idea is definitely not new. So there are definitely people who have already been doing it much more extensively, much more well organized. Okay, so what I'm doing now is really on a very, very small scale. Okay, the motivation is to let my current duties to get more resources instead of just waiting for me to come down every week for tuition. So I see that, in fact, a lot of people out there are not coming forward for tuition for a couple of reasons. Number one could be financial. Okay, people might not be hearing, people might not be seeing or finding a need to do tuition, maybe because of financial issues, or maybe because they feel that they are just able to cope on the minimum line for them not to take tuition. So maybe they will tell themselves, hey, if I were to just focus more in class, then I will be able to catch up with the classwork. But sometimes when we see homework questions or we see exam papers or prelims, we might get a bit stuck, because sometimes the questions might tweak just a little bit, and then when your foundations are not strong enough, you guys will you'll hit obstacles lah. Okay, so that's why I created all these channels and resources for everyone to tap in, to actually interact. Okay, so I always believe that learning is more of a mutual process. Okay, I always tell my students, the more you all ask, the more I will share, the more you all learn and improve. If you guys don't say anything, you guys keep silent, and then there's nothing much that I can share with you, because I don't know what you don't know. The worst thing in terms of understanding of knowledge is when you don't know what you don't know. Okay, that is like totally out of your league already. Okay, so at least today, as you come onto our channels and our Discord servers and our Zoom meetings, okay, at least you guys come with certain questions that you want to ask. Okay, so for example, you might be asking, because last week I had a good interaction with a couple of them, and then some of them say, hey, this week I want to come in again. I want to hear more about trigonometric ratios. Okay, so at least they have an idea of what they want to hear and what do they want to revise on. Okay, so when they come in with questions and I answer them, I teach, I guide along, hey, it is very clear that they are learning something. I think that is a more effective way of learning. Okay, I understand that there's a lot of tutors out there that is doing, they have a prefix of questions and a preset of topics that is being done. So for example, I say, okay, today I do trigonometry. So this entire session I do trigonometry. Then next week I do maybe Pythagoras theorem. I do another whole series of Pythagoras theorem. That I feel that I'm not at that level yet. Okay, I'm not at that level yet. Maybe in the future, but I really don't want to enter that area, because number one, there's a lot of people out there doing it. Number two, I want to make this more of a freestyle platform. I want you guys to just come in and ask whatever questions you all need. So if I may have like set one coming in to ask about our basic algebra and simplifying, and then after this set one leaves, another set 4 comes in asking about maxima, minima, rate of change, and then he leaves. And then the sec 2 comes in, talks about maybe statistics, bar graph, histogram, pie charts, and then sec 3 comes in asking about standard deviation. Okay, it can be anything under the sun, as long as it's between primary school max to sec O level. I don't say sec 4 lah, because there are people who are sec 5 ma. Okay, so sec 4 people who are also doing sec 5 students doing O levels, they can also come in to ask as well. So I want to make this as freestyle, as open as I can. Okay, I know that there are tons of other platforms out there that are also doing like streaming. Okay, I'm effectively bilingual as well. So if you want me to converse in Mandarin, no problem with that. So right now, Discord, Zoom, and YouTube is what I'm focusing on right now for English. I'm not sure if I want to stream onto Mandarin at the same time, or maybe I set another day to do Mandarin. I don't have much time, by the way. So every week, 3 hours is the maximum I can come up with to do like an open interaction, because I also do tuition assignments as well. Okay, so of course in Mandarin we have places like WeChat, and then we got things like Xiaohongshu. Okay, all these are amazing platforms. The crowd there, the market there is also very big. Amazing. Is the potential is amazing lah. It's really a lot of different opportunities that we can tap into. Okay, but I want to focus more on the English market first, and also to target for like our students over here lah, who are still doing all these English platforms. Okay. Okay, so and also just a quick update about what have been done so far. Okay, so for those of you who are still not aware, okay, for the first time, apart from this weekly quickfire sessions that I'm doing from 5 to 8 every Thursday, I also am setting up the 2 Telegram channels, which I've also included in the Discord and the YouTube channels. Okay, at the same time, I'm also creating my own database of study notes and question banks. Okay, so for those of you who are looking in terms of self-studying, you all need some concise study notes, and also questions for you all to practice on. Maybe can be the most basic things like your highest common factor, lowest common multiple, all these things. Or it can be as extensive like finding the equation of a circle, and then the equation of tangent and normals. Okay, so like I mentioned earlier on, I've tapped into the global server of mathematics. They are pouring in questions every second. All right, there are like I can't even count how many people are there right now, and they have like I don't know, more than 30 plus help channels. It's crazy. I see if I can able to find the number of people over there. It's humongous. I see the number of people over here. It's like 14,000 people online. It's crazy on Discord. That means 14,016 people online, and then I have like another category of 14 people, and these are only people who are online. Not to even mention this Discord server comes from America, comes from the Western countries that at their time zone right now is actually nighttime. So these people are actually studying into the night, and then they are being active on the Discord server in the night, at night. So imagine while we are sleeping here in Singapore, while we are sleeping, they are active. So I cannot imagine how many people is going to be active on Discord in daytime on the American side. Okay, it's kind of crazy. It's kind of crazy. So I'm just doing I'm just doing what I can here. I'm not sure if I can see the network over here. Oh my goodness. I just saw their whole network of different Discord servers, from electrical engineering to chemistry to neuroscience to aerospace to climate science to computer science to AI to physics. Okay, I got the exact stats. There are 18,000 people online right now. Right now, while I'm speaking, is 18,000 people who are online, and there's a total number of 147,000 members in the Discord server. And I'm only talking to about 10%. Right now, only 10% of them are online. Then there's 18,000 people. you can see how big the Discord server is just based on the subject of mathematics itself. It's I would say it's really, really crazy. But I see a lot of potential network and opportunities over there where I can also extend my help to more people out there. Because all these people who are here, and that we are extending our help to, we have no idea where they are. We have no idea which country they are from. We have no idea which grade they are in. As long as they post a question there, and someone can go in and help. Like literally anyone, as long as you tag yourself as a helper, then you can just go in there and just slay it. So I'm receiving a lot more questions from these networks for me to enrich my question bank and to reach out to more of you guys, to give you guys more opportunities to learn. Okay, this is the opportunities are really endless. Once I got into Discord, wow, this is really a big sea of opportunities over here. Okay, so maybe I just take this opportunity to share with you guys the database that I'm working on. Okay, see if I can show it you guys here. Okay, so as you can see, I'm actually still typing one of the questions down. So it's not really, let me see if I can share it on Discord server. Turn on camera, share your screen. Oh, I can. Wow. Go live. Okay. Open system settings. I need to try this out, man. And oh, okay. Maybe I'm not able to show my screen. But I think it's fine. Maybe I can just share my screen. Okay, I stop streaming first. Okay, turn on camera. Okay, so yeah, I'm back on Discord. So what I'm doing here is wow, this is a lot of things going on. See, I can minimize this. Focus, inbox, more, chat. Okay. Okay, can. So what you guys can see right now, for those of you who are on YouTube and on my Zoom meeting, you guys are actually seeing my question bank. So I'm actually writing down a question I just got this on Discord. I just absorbed the question from Discord. I came up with my solution and then I'm going to put it here. Okay. So this is what you're going to get occasionally when you all enter the database. So I will put the questions and answers over here. I'm still in the midst of typing it, so it's not complete yet. So this is for Sec 4. So I'm trying to actually bit by bit go and enhance my database over here from Sec 3. Okay. So what do you guys? Okay, so this is to show you guys the whole outline. Okay, so we have study notes, we have question banks, and then I'll be also typing some articles as well. These articles, right, may be relatable to primary school, to secondary school, or both. Okay, so these are just like extra reads for you guys to enhance the knowledge. Not some of them are into specific topics, some of them are not. So once I open this database to everyone will be able to access all the different articles. Right now, what you guys are seeing on your Telegrams, on your Discord servers are just like individual links to individual articles. Okay, so once everything is up and all the system is ready, I'll be releasing this system to the public. I'm not sure how am I going to monetize this. As of now, I don't have the how do I say? I don't have the plan to monetize it at the moment, which I don't think I'm going to do that. But of course, I don't want to put myself away from monetizing it as much as I can. I try not to. So yeah, so this is where I hope to offer as much of my own initiative to everyone. I don't earn any single cent from all these things. So it's more like ongoing passion project. Okay, can. Okay, speaking so much, I'm actually still waiting for people to actually come into my servers and also my Telegram channels as well. Okay, so of course, since last week we have some requests asking about teaching about the trigonometric ratios. So maybe what I will do is I will be starting from there, and then you guys can actually ask me questions from there. Okay, if you guys don't have anything in specific, I will just be taking random topics from anywhere, but I'll be prioritizing more on secondary school topics. Okay, secondary school topics. Okay, I won't touch so much on primary school students because I see that primary school students are more unlikely to come in. Okay, on their own, unless the parents open the stream for them to watch that. Okay, so this is mainly still focusing on secondary school people, but of course, if so happens there are primary school students who are coming in, okay, feel free to interact and then to ask questions and all. Okay, the asking is always taking the first step. So once you all ask, you all will be able to receive. Ask and you shall receive. Okay, so let me try to share screen from here. And apparently what I see from my YouTube is I'm still quite slow. I'm still showing my Notion database. Okay, so nevertheless, I see what I can do from here. And then share screen preview permission. Okay, I think I might need to stop my Discord for a while for it to restart so that I can share my screen. Okay, let me see if I can do it. Okay, go live. Does not have permission. Actually cannot. I don't need to share my screen. Okay. Change windows. Amex work. Zoom meeting. So that means if I were to hang on. Screens. So if I were to share my Zoom screen, I will be able to let everyone see my shared screen onto my Discord server. Oh wow, this is the way I can multi-stream. Okay. Awesome. Okay. That is very cool. That is very good. So I make co-host. No choice. I have to come up with all sorts of different way of working things around to make it work. Okay, so right now you guys should be able to see this screen to notify my friends in server that I'm streaming. Yes. Better text readability. Okay, 随便. You might get unexpected results. Okay, sure. Okay. Okay. So on my left-hand side, what the Discord people see will be the Discord server itself. Okay, I'm still trying to sort things out. Okay, at the same time, I'm also live. Okay. Can. Then now on the Zoom will be my screen, my iPad screen. And then on YouTube, you guys should be able to see the iPad screen as well. Okay, so 3 places you guys will be able to see. This is good. I'm still trying to meddle things up. Okay, but of course, okay, now I got another streaming idea already. So I can put it on Discord, I'm on Zoom, I'm on YouTube. Okay, maybe I can screen record the entirety of this thing and put it onto Facebook. Or maybe Twitch. I'm not, maybe not Twitch lah. Twitch is more for gaming, but maybe Facebook. So Facebook, YouTube, Discord, Zoom. Wow, all at once. I think my computer will explode, but I think my MacBook will not fail me. Okay. Okay. Hopefully my don't hang or something. Okay. In fact, I can even plug in my second laptop to broadcast to more places. But I think that should be fine. Okay. Oh yes, one more thing. I can also do my live stream onto my Telegram channels as well. So right now I'm going to start my Telegram live stream. Okay, the bad thing about Telegram live stream is just that they can only hear me on voice, so they won't be able to hear me. They won't be able to see me, like, in a sense. Okay, they might be able to only see my face, but I think not enough. But never mind, I'm just gonna put it here. Okay. Okay. Let me sorry. Okay. Did I? Hang on. Where's my screen? Oh. Okay. My screen is back. Sorry. Okay. So gonna put it in. So okay, and then for people who are coming in from Telegram, you guys will be able to join in as well. So I'm on Telegram, I'm on Discord, I'm on Zoom, and I'm on YouTube. I'm also actively watching out for all messages coming from all platforms. So if you guys see, we pause this preview to save your resources. No, I don't want to save resources, just keep going. Okay, keep going. Yeah. Okay. Of course, I welcome questions and comments from all platforms. So I'm ready to handle it from everywhere. So just like bring it on. Like bring it on. Okay. Resources. Okay, good. I see all the chats are here already. Very good. Well done. Well done. Okay, maybe I just put it elsewhere. I have a Zoom meeting chat, a YouTube chat, a Discord chat, and a live stream. Okay, awesome. This is great. Okay, so today I'm going to just start on trigonometric ratios because I've received requests on doing that. And then later on, I'll also be moving on to some Sec 1 starter topics. Okay, I have, very interestingly, I've encountered people who are actually not at secondary level yet, but they actually want to do, like, they want to learn in advanced secondary school stuff. Things like quadratic equations, things like linear equations. Linear equations sound very easy to secondary school level, but for primary 5 students, for primary school students, they might be, it's still quite abstract because for primary school students, you guys are still learning about models and then using boxes to represent unknowns. So as we transit from boxes to using letters, it's getting more and more abstract. So we need to understand, for primary school students, they need to understand the concept of drawing models first, using something that's visual to actually represent unknowns and solve for unknowns, blah, 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 before we move on to like equations. Okay, but I'll talk about that later on. Okay, so about trigonometric ratios, another whole big topic we are talking about. The person who requested for this is actually a Sec 3 student. So I'll start off with the most basic of trigonometry. That means you understand what is your sine, what is your cosine, what's your tangent. We need to understand what are these first. This is the first step. After we understand this already, we need to understand the trick of special angles. Okay, this is the second step. After we learn about these special angles already, we need to learn about the trick. That means the trick of our supplementary and your complementary angles. Okay, so there's a couple of things that we need to learn. For example, if sine 60 is of a certain value, sine 60 degrees is of a certain value, then what is sine 120 degrees? So all of these will come in at a later phase. Okay, then trigonometry of such angles. Then we also have like things like evaluating other angles. Like, for example, we have weird things like sine 15, which is something that is not really common, but is still tested. It can be tested in our official exams. Okay, then we also talk about things like your double angle formula. Okay, double angle formula. And then we also talk about things like how we apply trigonometry to other things, like, for example, your sine rule, your cosine rule, your double angle formula, your half angle formula. Okay, all this will come in later on. And then also talking about proving trigonometric identities. Yes, identities. Trigonometric identities. Okay, so in secondary 2, you guys learn about algebraic identities. I keep talking about the 3 sacred lines, the 3 sacred lines, the 3 sacred lines. So when it comes to trigonometry, there are also certain identities that we need to memorize as well. Okay, I understand that these identities may be given to you in the formula sheet. Okay, but it's always best to understand what they mean. Like for example, your sine square plus cosine square is 1. Okay, and then from there, what else can we derive? Okay, these are quite basic stuff that where we need to align first before we go on to solve other types of questions. Okay, we got a lot of things to cover. You see, just on trigonometry itself, I already point 1 to 6. Okay, there's really a lot of things. So for example, this person requested that I want to do trigonometry. There's really 1,001 things under the sun. Unless you have a very specific question or specific aspect of trigonometry that you want me to do, then we can go straight into that area. Okay, because after that, once we learn all this, we still have the calculus of trigonometry. So for example, I can differentiate my calculus, I can integrate my trigonometry. So for example, I can say when I differentiate sine x, I get cosine x. I differentiate cosine x, I get minus sine x. I differentiate tangent, I get secant square. Okay, so this is all of these are also is also related to trigonometry, but it's on a very much higher level. So it's best that you guys can come in with specific questions. That is when we are able to make the interaction more specific and more up close. Okay, so these will be the things that I will be going through. I don't think 3 hours is enough. I don't think this 2.5 hours is enough for me to go through everything. But I try to cover from 1 to 4. At the very least 1 to 4. Okay, that means learning sine, cosine, tangent on the most basic level, the special angles, the supplementary and complementary angles, and evaluating other angles. I think this is enough already. It's quite a lot already. Or you have other specific things that you want to go through, want me to go through, you all can also let me know as well. Okay. So in the meantime, let me just direct my Facebook people over here as well, in case if they want to watch it. Okay, should be up already. So yeah. All right, okay, that's good. Okay, so let's start on the main content today. Okay, Ken. So we are now looking at trigonometry. So let's kickstart the whole thing. Okay, so of course, where is the first time you guys will see these three things? Your sin, cos, tan. Okay, some people call it sin, cos, tan, because how do you differentiate whether this person is from upper sec or lower sec? Is how they pronounce these three things. If you see people looking at the calculator and then tell you, oh, this little signage over here called sin, cos, tan, you know that this person haven't learned trigonometry yet. Okay, so if the person has already learned trigonometry, the first thing they will tell you is sine, cosine, tangent. So essentially, what are these things anyway? Okay, so before we go into learning these three terms, we need to understand that all these things comes from a right angle triangle. Okay, this is a basic and this is a must. And then for a right angle triangle like this, okay, we can call any of these. Let's just call this angle theta. Can I call the other one theta as well? Of course, no problem. Okay, but in this case, for convenience, we put it over here at the bottom. Okay, so let's just call this theta. Okay, so once we have a right angle triangle being set, and then we have the angle in perspective over here being confirmed, that means there will be certain lengths of the triangle that we need to establish. Okay, number one, the first one, the most easiest one, which is the longer side. The longer side is what we call the hypotenuse. We need to know this one first. No matter which angle, which theta you're looking about, we are talking about the hypotenuse. The hypotenuse is always the long side, the longer side, or some people say the diagonal. Okay, that is the first part. Okay. Yeah, let me see. Okay, so this is the first one, hypotenuse. Okay, now the next one, we have this length over here. This length is called the opposite. Okay, you just remember as OPP. Then hypotenuse is a HYP. Okay, so how do we know it's opposite? When this line is opposite the angle theta. Okay, so you see that depending on where the theta is, the hypotenuse may change. Okay, very important. The hypotenuse, no, the opposite will change. The opposite will change depending on where you set your theta. Okay, so after this, once we got a hypotenuse, we got the opposite. Just remember, opposite line is always the opposite of the theta. Okay, that's why it's called opposite. Okay, and then the last one we have over here at the bottom will be called the adjacent. Okay, so this is the three lines that we always talk about: hypotenuse, opposite, and adjacent. Okay, so we need to get at least this is the first basic step before you even talk about any trigonometric ratios and whatsoever. This is the first thing that we talk about. Okay, then after that, let's bring in these three things. So essentially, what are these things anyway? How do we use them? Where do we put it in equation? And because they're just purely like words, sin, cos, tan, how I know where are they supposed to be in? Okay, in fact, this one, okay, so first of all, we need to clarify what are sin, cos, tan. What's that? Okay, so when we say we learn trigonometry, okay, this is the whole topic. The whole topic is called trigonometry. However, this sin, cos, tan thing, okay, these are called trigonometric ratios. They are a ratio. Okay, this is something that it's very, very simple, but it's very often being overlooked. This sine, cosine, tangent, right? They are actually called ratios. So when we talk about ratios, we are talking about two things, and then we are comparing the proportion of one another. Remember in primary school when we learn about ratios, the number of boys to the number of girls is 7 to 4. Okay, so this is like a ratio because I'm comparing the proportion of the number of girls to the number of boys. So when you talk about a ratio, we are comparing two quantities. Okay, we need to get this down first because ratios is like we need to understand what ratios are. Then we can know what are these three things happening. What does these three things actually mean? Okay, so we talk about trigonometric ratios. What does it mean? That means this three sine, cosine, tangent, these three ratios are actually taking different lengths of this right angle triangle and comparing the proportion of it. Okay, so how do we write them properly in a proper equation? Okay, so for example, okay, so at this point of time, you guys would have heard of the textbook, like what they teach you, they call it the Tuakaso. Okay, how many of you heard of the Tuakaso thing? The Tuakaso thing. When I first learned about it, I also learned about Tuakaso thing, but I think I grew out of it. I kind of grew out of it. I said this is like a very cliche way of doing it, but yes, it seems to be what it is. But I don't really talk about this Tuakaso thing unless I'm only teaching it for the very first time. Okay, so Tuakaso, what does it mean? Okay, how does this Tuakaso help us to remember stuff? Okay, oh, Tuakaso, sorry. So it's actually CAH. Okay, you see, I don't even remember the acronyms. Okay, so basically, what does each of these things say? Okay, where we have TOA, what does it mean? When I talk about tangent, okay, I'm referring to the opposite over the adjacent. Okay, opposite over adjacent. So if you go back to the right angle triangle on top, it's the opposite versus the adjacent. So you can see that what we are looking at is always the perpendicular lines. But of course, which one do we look at? We look at the opposite first, then we look at the adjacent. This is quite important as well. So we need to, instead of adjacent over opposite, we are looking at opposite over adjacent. Okay, perpendicular lines. Okay, so this is the opposite over adjacent. This is for the tuakaso, the tua part of the tuakaso lah. Okay, it sounds ugly lah, but yeah, that's how people remember it. Okay, the next one, cosine, because it's a C. So cosine, we are referring to the adjacent over the hypotenuse. Okay, adjacent over hypotenuse. Going back to the right angle triangle, which part are we looking about? Adjacent over hypotenuse. Okay, so you can see that the adjacent over hypotenuse, right, is this line over here. Oh, sorry. This line and also the longer side. So you can see it's actually the two lines actually touches and meets at where the angle theta is. This is how we remember it. Okay, and also lastly for the sole part, it will be sine equals to, not equals, I'm just referring to what the ratios are. Opposite over hypotenuse, which is the other two. Okay, so I remember it this way lah. I don't really remember by the tuakaso method anymore. In fact, the more you guys practice, the more familiar you guys will be lah. Okay, so you guys will be able to remember this. Just remember this for the very first time. After that, you all can just the more you all use, the more familiar you guys will be. Okay. Okay, moving on. So how does this sine, cosine, tangent work, and how do we put it here? Okay, after we establish how these different ratios relate to which two lines are they comparing in terms of the proportion, okay, it's time to put them into the perspective. Okay, so combining these three things and combining what we have on the right angle triangle over here. Okay, so you can see that the theta is over here at the bottom right hand corner, and this sets the position for the opposite and the adjacent lines. So how do we put it in a proper form? Okay, let's start with tangent. Okay, this is how you write it. The ratio, and then followed by the angle, so it's in degrees, okay, will be the opposite line over the adjacent line. This is how you write it. Okay, so to show you all the format very clearly, this is the ratio, this is the angle, and then this is your fraction. Okay, I just put it fractions, okay, because what the numerator and denominator is may change depending on which ratio you're using. Okay, I'm just going to show you the syntax of writing it, because up to this point, there are still people who write tangent fraction equals to an angle. Okay, that is absolutely wrong. Please get it clear first. Okay, so we need to make sure what are we writing. So ratio of the angle equals to the fraction. Ratio angle equals to fraction. Okay, we need to get this syntax down. Very important. Okay, so I'm going to highlight this one. I'm going to put it to the side. Okay, so just now, okay, let me just erase this one. I'm going to shift this to the side as well to let you guys see how it works for the other trigonometric ratios as well. Okay, moving on. Now I have tangent theta equals to opposite over adjacent. That's the first one. Okay, then we have the cosine. So how do you write for cosine? Cosine theta equals to adjacent over hypotenuse. Okay, same thing. It follows the same format. Ratio angle equals to fraction. Okay, and last one, following the same format, which is sine, which is equals to your opposite over hypotenuse. Okay, so this will be the three very important ratios that we are talking about for the rest of the session today. Okay. And I think my Wi-Fi got hanged. I think because there's too many people over here and I'm using too many devices. And right now there are a lot of people out there working here. Okay, so while I'm waiting for my Wi-Fi to restore on my iPad, just to let you guys know, I have a office over here in town in Tanjong Pagar. So for those of you, for students who want to, to find a place, a conducive place for you to study with aircon, with power plug, with high-speed Wi-Fi, and really 100% privacy, you guys can reach out to me. Okay, let me see if I can arrange for you guys to actually come over to study on your own. Okay, maybe for a couple of times, or maybe for that final exam sprint that you guys are looking at, because I understand that right now, in exams, when it comes to exam periods, it is very difficult to actually find study spaces in the library as well, especially when people walk around. And then nowadays, I see that for open study spaces, you guys need to actually make a booking as well. So actually, you can okay to sit anywhere. But if someone actually reserve that spot for that timing, and they come to you with the reservation confirmation, you have to get out and move somewhere else. This is what I see for libraries. Okay, unless you are working in cafes lah. But I believe if you are really going to choose a place as working at cafe, means you're not going to study for real. Okay, unless you are really, really self-disciplined and focus on your own thing, because there'll be people moving around, buying food. Wow, the food smells very nice, you want to eat, then you'll be distracted. Unless you tell me that, hey, you really can set the self to be very focused and disciplined, then to study. Otherwise, don't do at cafes. Starbucks lah, Coffee Bean lah, Coffee Smith lah, where else? Okay, don't study at cafes. Study at cafes don't work. Don't work. At least it don't work for me lah. If you really want to study at Mark, really go to a private 100% quiet space, or at least a space where you can stay unobstructed, undisrupted for a couple of hours. Only then you call it studying. If not, you don't cheat yourself. Really, don't cheat yourself. Okay, I think the Wi-Fi is suddenly turned quite weak. I'm trying to restart my Wi-Fi over here. Okay, so of course, if there are any questions or anything specific, you guys can actually let me know. I'm trying to restore my Wi-Fi connection over here. I'm able to connect. Come on, it was connecting so well just now. Let's go down there. Let's go. I was in the middle of my class. Okay. Okay, I'm in. Yes. Stay host. Yeah, should be up by now. Yay, awesome. Okay, I can continue my class. Yay. Okay, now where are we? Now we've established tangent theta, cosine theta, sine theta, all these things. Okay, so of course, for example, moving on from here, we have understood this already. How do we actually put it into a calculator to solve for certain things? So that means, right, for example, if you turn on your calculator today, okay, and then you press sine, and then you press some sort of angle. You press some sort of numbers, like it can be an angle, it can be a fraction, it can be anything. But for example, let's say I key in sine 60. Okay, so you all can take out a calculator and press in sine 60. We all press sine 60, you all will get 0.866025403, blah 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 blah. Okay, so that is the ratio. Okay, so that means it's actually opposite over hypotenuse. That means if you take the angle, okay, what does sine 60 mean? I'm going to put it over here. That means to relate it back to the right angle triangle that we are referring to. So that means if this theta is 60, okay, I'm looking at sine 60 equals to 0.866 something. Okay, so if I were to key in the calculator, I'll get this ratio. What does it mean? Okay, remember, sine theta is opposite over hypotenuse. What does it mean? So that means this is a fraction over 1. So what I'm saying is, if this adjacent line is 1, if then this number will be 0.866 something. Because I mentioned it is a ratio. It's a ratio comparing the proportion of the length of the length of two sides of the triangle. Okay, so opposite over hypotenuse. Okay, that is the fraction. So when we key in the calculator and you get a value, that whole string of decimals that you get, it is the fraction. Okay, obviously, it's not a very nice number if you go to, because there's no way you can press the calculator and then get it into a fraction form. Okay, for some fractions, yes, but for most of them, no. Okay, so you must always understand that even if they come out with some weird ass decimals like this, it is still a fraction. It is still a fraction. Okay. Okay, so now this is, so you can go ahead and continue to try different types of values. For example, tangent 75, for example, tangent 100, for example, cosine 150, for example. You guys will get a whole series of like weird looking decimals. Okay, it is totally fine because all of these, like I mentioned, all of these are proportions, all of these are ratios. Okay. Okay, so of course, whether is it a rational number or whether it's an irrational number, that is not important because like I said, some of them are, some of them aren't. It doesn't matter. You just know that it is a fraction. It is a proportion of two sides. We need to establish the understanding up to this point first. Okay, so this is about the how do we write the trigonometry ratios in a proper format. So if you write the ratio first, whether is it sine, cosine, tangent, then you write the angle, then we write opposite over adjacent, or whether is it adjacent over hypotenuse, opposite over hypotenuse, depending on what you are looking at. Okay. So this is like the most basic. So of course, if you want to do some sort of practice, okay, we must be able to quickly, of course, we are required to quickly identify what kind of things are we looking at. That means you see back to here, we are given a ratio, an angle, and a fraction. Okay, with all of these things as part of a grammar, as part of the syntax, ratio, angle equals to a fraction. Okay, so at this point of time, we understand this ratio, this whole format already. So we must be able to know if we are given for example, if you are given a fraction, we must be able to find the angle. And if you are able to find, if you are given the angle, and maybe you are given the opposite, we need to find the hypotenuse. So that means they will give you one unknown, but they will give you the other information so that you need to choose the correct ratio to use and then to plug it in and solve for the value. Okay, so this is the first most basic requirement and the most basic understanding of trigonometry. Okay, so here's an example. So I'm still going to give you the same, I'm going to give you an example. So for example, I still have this same right angle triangle over here. I say this is 60. Okay, maybe not here. I make it simpler. Maybe this angle here is like 30. Okay, 30. And then they give you an example. Maybe they give you one of the lines. Okay, they give you one of the lines, which is 2. Maybe they tell you that the hypotenuse is actually, maybe they give you 2 cm. Then they ask you, what is this? Okay. So at this point of time, you're asking, okay, because I'm given the angle, I'm given one of the lengths, that means I will be able to find the other length of the right angle triangle. So at this point of time, what are the steps for us to go and solve this kind of problem? Number 1, this is the first step. Determine whether, so you need to determine which ratio to use. If you use the wrong ratio, you don't need to talk about anything else really. Okay, ratio to use. whether is it a sine, whether is it a cosine, whether is it a tangent. Okay, because depending on what is given and what we are required to find, we need to select the correct ratio. Okay, so in this case, let's identify the sides first. Number one, this is the hypotenuse. Given. This is the opposite, and this is the adjacent. So how do we know what we need to use? Okay, we look at what is related to the question that I'm asking for. Okay. So in this case, I'm given the hypotenuse. I'm required to find the opposite. Okay, I'm given the angle. So which ratio links the opposite and the hypotenuse together? Okay, the answer will be sine. Because remember, sine, so we put in the ratio according to the syntax, which is ratio, then the angle, then the fraction. Okay, so let's put it in over here. So to put it in the proper way, so it will be sine, which is the ratio, followed by the angle, equals to, okay, remember, we go back, right? So means sine is opposite over hypotenuse. So opposite, which is something that I'm looking for, and over the hypotenuse. In this case, I don't know what the opposite is. I'm supposed to find what the opposite is. But am I given the hypotenuse? Yes, I am. Okay, therefore, sine 30 equals to opposite over 2. Because this 2 cent is given in the question. Okay, so this is the way to do it. So from here, how to solve? This from here is very simple already, because it's sine 30 equals to opposite over 2. Then solve for opposite. The opposite equal to 2 sine 30. So all you need to do is calculator. Then you realize it's 1. Okay? Okay, so you key in 2 sine 30. 2 sine 30, you get 1. Sub to 1. Okay? So opposite will be 1. And what does this mean? That means if the hypotenuse is 2, the opposite must be 1. It cannot be other answers. It cannot be other answers. It can only be 1. And since it's a proportion, because we put it back here, and let's extend on this and discuss. So what it means is that sine 30 is half. That's what it meant. That means if the hypotenuse is 2, the opposite is 1. And from here, we see that it's actually a proportion. It's not coincidental that it is a half of the hypotenuse. It is always the half of hypotenuse. It is always the same proportion. Remember, this is a proportion question. It's a proportion question. So that means if I were to extend this further and I ask you, so what will be the length of the opposite if the hypotenuse is 4 cm? Let's say today is not 2 cm, it is 4 cm. So what will my hypotenuse be? Half. Half of 4, 2. You see that? Because it is always opposite over hypotenuse is half. Therefore, opposite will be 2 if the hypotenuse is 4. And likewise, for any other numbers they may come by, let's say they like to extend it even bigger, they tell you the hypotenuse is 100 cm. And then they ask you what's the opposite. Then so be it. Opposite is still half of the hypotenuse, 50 cm. Okay? So it is, remember, this number is always be fixed. That means as long as the angle is 30 degrees, as long as the angle is 30 degrees, the opposite will always be half of hypotenuse. That is what it means. Okay, it's not coincidental. It is not coincidental that one of them is half of the other. It is always the case. Very important here. So therefore, sine 30 is half. That's what it meant. Okay. So of course, with this in mind, just now what we have given is I've given you a side, I've given you an angle to find, and then we find another side. can I also give you the ratio instead? I give you the length and then you find the angle. Can we do that? Of course we can. Okay, so imagine today now we got another type of questions. Okay, of course, all of this, the premise is that it must be lying on a right angle triangle. Okay, so in this case, it is still a right angle triangle. Let's use another example. If today, I mark out this angle, what I'm looking for is unknown angle theta. Okay, the opposite will be 1 and the hypotenuse is 3. Okay, now you are given two sides. You are supposed to find the angle. Okay, let's put it somewhere else. Let's put it over here. 2. Let's say now the adjacent is 2 and the hypotenuse is 3. Okay, so from here, they say find theta. Okay, so we always go back to the first step. What was our first step? Determine which ratio to use, which is sine, cosine, or tangent. The second step, of course, is to go in and plug in the values, and then we can solve. But first of all, we need to know what ratio to use first. Okay, this is the most basic one, of course. Okay, so the first one would be the theta. Theta is here. I need to know what is my sine, cosine, or tangent. So first question, sine, cosine, or tangent. Okay, same thing. To determine this, we need to see what we are given. We are given the adjacent. We are given the hypotenuse. Okay, so in this case, A and H. So which one I will be using? I will be using cosine. Okay. So from here, plug it in. Put it in the same format first. Before we plunge in to calculator and press, and then you get the wrong answer, write it in the proper format first, then we know what to do. Okay, so we're doing cosine. So we write it in. Remember, ratio, the angle, in this case is unknown. The angle equals to 2/3 because it's adjacent over hypotenuse. Now, next question. How do we solve? Okay, so we have done the step 2, which is we plug in the values. But number 3, how do we solve this? Okay, so just now at the previous example, okay, I put it sine 30 equals to something over 2. Then I press that opposite equals to 2 sine 30. That is what I got in the previous example. Okay, so now here, what are we looking for? We are now looking for the angle. We are given the sides. We need to find the angle. So what exactly we need to do? Okay, so here is the most important part. Okay, to solve for the angle, we do the ratio inverse. Okay, to find the theta. That means what? In fact, informally, what we are doing is we are bringing the cosine from the left hand side to the right hand side. Okay, so you see that just now I got cosine theta equal to third. Now I got theta equal to something. Okay, so the so-called the reverse of cosine is actually called cosine inverse 2/3. So this is how you properly write it. Okay, I don't want, okay, try your best not to remember, oh, theta equal to cosine inverse, whatever. Always derive it from this step 2. Don't remember step 3 on its own. It is very difficult to do so. Just remember cosine theta is 2/3. What do I need to find? I need to find angle. If I need to find angle, I inverse that ratio. I inverse that ratio. So what is this called? This is called cosine inverse. Okay, a lot of new terms today. Cosine inverse. Okay, now we know what to write, but how to calculate? How to solve? Okay, and what do we key in the calculator? Okay, so if you go in and see the calculator, okay, on top of the respective ratios, right, you will see like the same ratio with a -1 sign there. Okay, very weird -1 sign over there. Okay, that is your inverse of that ratio. So in this case, you just need to plug in cosine inverse. So for me, is second function. I believe for most calculator models should be the second function as well. So second function cosine inverse, the cosine inverse sign will come up, and then you press 2/3. Okay, so cosine inverse 2/3. Okay, and then you'll get this another whole bunch of decimals come out. Okay, in this case, you should get 48.1896851. Of course, this answer will go on and on and on and on, but I don't really care because I'm looking at angles to the nearest one decimal place. So it's 48.2. Okay, so remember, when you do a cosine inverse, the answer you get is still a decimal. However, this decimal, right, is the angle. It's not the length or some fraction anymore. It is the angle itself. Because you see in this equation, we are looking for the angle. So the answer that you get will be an angle. So you just need to round it off to 1 dp. That will be answer A. So that means in this case, if I were to put these values back into this equation over here, that means the value of this theta will be approximately 48.2 degrees. That's what it means. That's what I mean here. Okay? Kinda. So it will be that's how it works. That's how it works. Okay, of course, so with this in mind, is what kind of questions would they give? What kind of question do they give? It really depends on. It's either there'll be one missing information, but with the one missing information, you must be given the two other information. Because you see in here, I use the example over here now. Just in the previous example, sine theta is half, and then cosine 48.2 equals to 2/3. We are given three things over here, and there are three variables that we can play with. One is the angle. Okay. 2 is the sides. So we must have a few things, okay, for the whole equation to be complete. So it's one of them must be missing to let you solve for that one thing. And then they give you the other two things. So what kind of two things will they give you? It's actually kind of straightforward. It's either they give you two sides, length of two sides, then you must find the angle. Or let's say they give you the angle and one side. Find the other side. That's all. You just need to know that two lines and one angle forms the equation. And then what ratio is being used, what ratio is being determined, that depends. That depends on what length, whether is it hypotenuse or opposite or adjacent, which one are you given. So depending on what line are you given, you go and choose the ratio that you're supposed to use. Essentially, that is all for trigonometric ratios, the basics, the basics. So this is like a type of questions. Type of questions. Like I would say this is the basic, this is like the level 1 questions. Okay, there are level 2, level 3, level 4, up to I think level 6 and 7. But this is the level 1 question, the most basic one. Okay, so normally it's like a one mark question in your, it's like a 1 mark question in your paper. It won't go more than 2 marks. It's pretty easy. If you don't know this, then I don't know what to say that, but yeah, this is like the most basic of trigonometry, of understanding what is your sine, what's your cosine, what's your tangent. Okay, please don't ask me why is it named like that. Okay, I have no idea why is it named like that. It has for tangent, yes, because it has deeper interpretation and understandings of it. Sine and cosine, there is a direct name for that, for these three terms in Mandarin, that allows us to actually understand it better. But just remember, sine is a curve. It's a curve graph. Cosine is also another curve graph. Okay, and sine is related to cosine. So because sine itself is sine, cosine is just cosine. They are actually related somehow. At this point of time, you don't need to know how they are related. You just need to know that they are related somewhere. Okay. Okay, let's take a short break. I need a toilet break. So I'll just leave this here. Any questions that can come in all through my different chats, whether is it from my Telegram live stream, for my Discord servers, for my YouTube chat, or for my Zoom meeting. Okay, you guys are free to post any questions over here for a short while. Then I'll come back and continue from this. Okay. Okay, I'm back. Yo, hello. Okay. What about you? My ball bag.
But I think I ate something funny.
You. Stephanie's pizza.
Can't.
You.
Maybe on check whether
Okay. Cool.
maybe the
Okay, let me take this chance to go and like ping my WhatsApp groups also. Okay, can. Let me just continue from here. Okay, so now I hope that everyone got a basic understanding of your sine, cosine, tangent. At least you know what these three things are. Okay, just number one, they are ratios. They are ratios measuring two sides of a right angle triangle and their proportions and their relative proportions. according to the angle that's given. Okay, so they can give you all sorts of values already, all sorts of angles already. Okay, so this is the first and foremost, the most important part of understanding what is sine, cosine, tangent. So that covers point 1 of what we have. Which is on sine, cosine, tangent. Okay. Okay, number 2. I'll move on to point number 2, which is on trigonometry of special angles. Okay. So for certain types of angles, we need to know very well the ratios of the special angles. Okay. So what are they? I'll just do it over here. Trigonometry of special angles. Okay. Trig of special angles. So why do we call them special angles? Because they relate to the different checkpoints on the sine curve and the cosine curve. Okay, but I just need to know that these are the basic angles. Okay, some people like to remember it in a table format. Personally, I don't. But I'm just going to show it to you how it works. Okay, so first up, the first angle that we have is called 0 degrees. The second angle will be 30. Third angle will be 45, 60, and 90. This will be the few most basic angles that we are talking about. Okay. So of course, it's quite obvious and it's quite inefficient for us to actually really just plot this table in your head and then go and memorize every single value correspondingly to your sine, cosine, tangent. Memorizing doesn't really work for me. If you like it, then good for you. You have big brains, but I think you can use your brain capacity for other things. Okay, so please don't go memorize this. I think it's sucky lah. I'm a more visual person, so I would like to draw it in a triangles, and then I will see and plot out the relative ratios of the things like from there. Okay, so let me just tidy up this table, and then I'm going to show you these two very special triangles that I will teach you guys on how to memorize your trigonometry or special angles. Okay, first of all, I will introduce you a right angle triangle. Same thing, everything still lies on the right angle triangle, but this time this right angle triangle is isosceles. So first of all, always draw an isosceles triangle first. This is the first one. Okay, so based on how we understand, how we remember our isosceles triangle, this base angle will be 45 degrees. It will always be 45, it will not be 46 or 48, it will always be 45. Okay, so this is the first triangle that we draw. And for this type of triangle, how does it work? If this is 1 unit, the opposite is 1 unit, the adjacent is 1 unit, the hypotenuse will be square root 2. This is the basic form. Okay, so all sorts of numbers that you get, as long as it is an isosceles triangle, this proportion will not change. Okay, later I'll show you guys how is it being used, but let me show you guys the triangles first. This is the first triangle that we're looking at. Okay, the second triangle, I'm going to erase the 1. I'm going to extend the triangle on the other side, the left-hand side of this isosceles triangle. That looks like this. Okay, I try my best to draw it as accurately as I can. Like this. Okay, this is good. So in this case, I have another triangle. This time, as you can see, it is not an isosceles triangle, but it is actually half of an equilateral triangle. Okay. So from here, I use the common area, the common angle of common side of 1, and then this will be 2, and this shall be square root 3. Okay, so this is how you remember your special angles. Okay, this is all you need to remember. Okay, and anyway, how do we construct these triangles? It's actually pretty easy. And then from this blue triangle, how do we get it in the first place? If we were to draw an equilateral triangle, okay, all sides will be equal, correct? So if I to say this is 2, this is 2, that means the bottom must be 2. And I draw a line down vertically. I split the equilateral triangle into 2 equal parts. That means each side will be 1. So that means if this is 60, if this is 60, this is 60, so the top here must be 30. This is how it's being done. So I just need to take half of it. I just need to take 1/2 of it over here, and I put it into the above diagram. That's how I get the special angles over here. Okay, so I hope that this method is a more, I would say, a more efficient way of doing so, as compared to remembering a table of values. Okay, but I haven't went to a table of values yet. You guys still don't know what the value is. But in fact, if you go to combine these two triangles together alongside with what we had learned earlier on, by comparing the Picasso thing, the sine is OH, T is OA, C is AH thing, you'll be able to put in all the values instantly. Okay, so really depending on what you are looking at, let's look to fill out the table. Okay, so sine 30. Okay, so for sine 30, let's look at sine 30. Where's 30? 30 is over here at the corner here. Sine 30. So sine 30, remember, sine 30 inside is actually the opposite over hypotenuse. So you can see from here is actually half. Sine 45. Where is sine 45? Sine 45 is here. What is sine of sine 45? 1 over square root 2. Okay, or some people say square root 2 over 2. Personally, I'm not very particular or anal about having the surds at the denominator. It doesn't matter. You just need a way to remember it. Okay, don't be too anal and too bug out about it, because this is not the final answer of the solution that we're looking at. Okay, sine 60. You see, to see sine 60, now is getting a bit more confusing, because for the previous few examples, my theta is always at the bottom left or bottom right. Okay, so in this case, how to see sine 30? How to see sine 60? It's quite easy. Just turn the triangle around. Turn the triangle around and position your 60 degrees such that it's at the bottom right. Then you see it the same way. Okay, that's how I see it. I just turn the triangle around, then I can define it. Okay, you see, as I tilt my head, I see that the opposite of the 60 is a square root 3. So in fact, this is actually square root 3 over 2. And then this one. Sine 90 is 1. Okay, very, very unlikely they will ask you about sine 90. Very unlikely. But good to know. Okay, so this is the first part. Now, cosine. Back to cosine 30. Cosine 30, just remember, how I remember cosine is the two lines that is enclosing the angle. C for close, and the C, the letter looks like closing it. It's like a U-turn. This is how I remember it. It's like a U-turn. So I just see what are the lines that is U-turning, that's enclosing the angle in check. In this case, 30. And I look at which one is shorter, root 3 over 2. So you can see root 3 over 2. Okay, then cosine 45. Cosine 45, same thing. The U-turn thing, you can see is actually over here. So it's actually 1 over root 2. And then we have cosine 60. Cosine 60 is actually half. Okay, and we also have 1. Okay. Okay, cosine 6. Okay, sorry, cosine 90 is actually 0. Sorry, my bad. Okay, so how people actually see it is that, the values of sine and the values of cosine is actually a mirror version. So if I know sine, I can know cosine. So I mirror it around. Personally, I don't quite like the idea. It's just a very nice way of putting it. I realize this is a very common trick among a lot of international schools. This is the trick they do. They learn sine first, then they mirror version the cosine. Okay, yes lah, makes sense lah, but I don't quite like it. If you like it, then good for you. Okay, and also in terms of memorizing the table, okay, how they'll do it is because because I mentioned earlier, 1 over square root 2 is actually equals to square root 2 over 2. So instead of writing 1 over square root 2 in the table, they write square root 2 over 2. Okay, so how they remember the top row, which is the sign values, is and this is over 2 so 0, square root 1 over 2, square root 2 over 2, square root 3 over 2, and 1. Then for cosine, very simple. You reflect mirror, then you mirror the values, then you get a cosine. I feel that it defeats the purpose of understanding the values. So sorry for those who use this table of values and you eat in your head like that. I'm sorry that it doesn't work for me. It doesn't work for me. I'd rather you take out these triangles, you go and understand and reinforce what ratios are you using and what ratios are you using and which two lengths are you comparing. I feel that's a more effective way. Okay, like I said, it's both ways work. Both ways work. But it really depends on what you want and are looking for and which one suits better for your learning. Okay, now for tangent. Okay, back to my method, not the memorizing table method. Okay, as for tangents, remember tangent is what? Opposite over adjacent. For opposite over adjacent, I will be looking at, back to 30. I will looking at the T. Okay, how I remember is T, tangent T. That means the two lines meet at a 90 degree. Okay, so for tangent 30, it's actually quite straightforward. 1 out of square root 3. Okay, and then for tangent 45, it will be 1. For tangent 60 will be square root 3 over 2. And then tangent 90, actually very good question. Tangent 90, I don't really, you'll see an error in your calculator. Tangent 0 is just 0. Or some say it does not exist because tangent 0 does not exist. Does not exist. Because it is already a 90 degree already. There's no ratio to it already. No more already. So it does not exist. Okay. So for this is how I remember it. And of course, how the other people use the memorizing of table method is when all they need to do is to take the numerators. No, this is root 3, sorry. Root 3 over 1. Okay. Or just root 3. Okay. So what the people who memorize the table looks like is when they take the numerator of the sine and the cosine and then they put it together. Okay. So why does this work? Because tangent is equals to sine theta over cosine theta. But this is on the basis that you understand why is this so. Personally, yes, it is like that, but I still want to ground my understanding on understanding tangent is an opposite over adjacent. Okay, I can show you why tangent is equal to sine over cosine at this point, but I don't think it's the right time yet. So personally, I don't like this method of memorizing a tables and then from the values of sine and cosine, you derive tangent, the values of tangent. I feel that it's something that is a bit like, it's like a quick trick. It's a quick trick, but it doesn't help your understanding at all. Okay, it's my interpretation and my opinion. Okay, don't flame me for this. Okay, like I said, both methods of understanding and memorizing the special values work. Just that I prefer one over the other. Okay. Okay, I'm gonna move this over to here. Yeah, okay, I'm gonna move this over to here. And then I'm gonna erase this thing as well. to make up more space. Okay. Of course, some of you may answer or some of you may question why tangent theta equal to the fraction of the other two. You see, I'm so confused. You see why? I already know that a ratio, like it's like a ratio of an angle equals to a fraction. Then why is like a ratio of an angle is equals to another ratio of an ratio angle over ratio angle? Then it's like all over the place. This is the reason why I don't really like to talk about this. But can we actually elaborate on this and to understand the definition? Of course, yes, we can. Okay, let's go back to the original let's go back to the original equation, which is this one. Your tuakaso. Okay, we always remember ratio angle fractions. Okay, now we are going to put this all together, and I'm going to show you that this actually works. Tangent theta equals to sine over cosine. Okay, let's recall. Tangent theta is what? Tangent theta is opposite over adjacent. That's what we know about tangent theta. Okay, now for here, let's look at this. It's actually sine, they say it's sine theta divided by cosine theta. So can I actually write it like this? Sine theta divided by cosine theta. Yes, we can. Okay, it's just a normal fraction writing into a division equation. It's exactly the same thing. Then sine theta, what have we learned about sine theta? Sine theta is our OH, okay? So opposite over hypotenuse, that's our sine, divided by cosine. What's cosine? Adjacent over hypotenuse. Okay, so this is what we get. Because why can it be written like this? Because it is just, the sine theta is just an expression of the ratio of opposite over hypotenuse. Okay, so in this case, we can actually do a very simple cancellation over here. I do my P6 division of fractions thing. Then I can do this. Then what I can see here, do you see that? Because what is on these fractions it's not like anything fanciful, it's just a length. It's just a measurement of length. Okay, therefore my hypotenuse can cancel. I will get opposite over adjacent at the end of the day, which is tangent. And this is the reason why tangent theta is equals to sine theta over cosine theta. Okay, so it so happens to be in this case. It is useful, but not now. It is useful when we want to prove we want to prove trigonometry identities at the level 5, level 6. This is only level 1. I want to stabilize the knowledge of level 1 first before I move on to other things. Okay, so the memorizing of tables and the how to divide these values on tables, I feel is a bit counterintuitive. So I don't really encourage these table values. But like I said, if you are already very well versed in table of values, so be it. Okay, I'm not like forcing you to switch over to the 2 triangles. Okay, but in the exam where you cannot produce the table of values, you are screwed. Don't blame me. I got say before already. Okay, so personally for me, I rather remember the 2 triangles. I can draw it together like this side by side, or I can draw it individually depending on what I'm looking for. Okay. So now, okay, so we have concluded on this the tangent equal to sine over cosine thing. I'm gonna just leave it one side. It's still useful I'm not saying it's not useful, but not now. Relax. We haven't learned how to walk. You all want to fly already. Okay, relax. There's still a lot more things to learn and to understand first. Okay, so how does this tangent how does this special values work, and why do we need to know the special values? Okay, and what does these special numbers mean? Okay, so as you can see from that whole values over here, we actually get a few very weird looking fractions. Like for example, let me just name them out. 1 over square root 2 is 1. Square root 3 over 2 is 1. And 1 over square root 3. These are the very weird values that we are talking about. Okay, these are the 3 things that we somewhat we know how to know how to identify them when they are in the fraction form, but we cannot identify them in the calculator because we use calculator to calculate our ratios. Okay, but they give you a whole string of stuff. You don't even know you don't even know the decimals actually relate to one of these fractions. And I know that there are some models, calculator models, that allow you to change from decimals to a decimals to fractions. Like for example, if you key in like 3/8, then you can switch between 0.375 and 3/8 interchangeably. But for these three fractions, you cannot do that. Okay, I say first, you cannot do that because square root 2, square root 3, all of these numbers are irrational numbers. So the calculator will not recognize it as a proper fraction. Okay, you may say that a calculator got show me value there 1.73 blah blah blah. That is only an estimation because the calculator's screen size is too small for you to display all the values. Technically, there is no limit to how many decimal places are there. That's why it's called irrational. Okay, so what you're seeing on calculator is just an estimate. Okay, it's just an estimate. So do not assume that it will change the calculator change the fraction on its own. Okay, what you will only see in the calculator is only a bunch of weird ass looking decimals, and it will stay it like that forever. So we must have the ability to recognize the decimals and convert and relate it to this fraction. Okay, so I'm going to share with you the three values. Number one, 1 over square root 2 is 0.7707 something 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 something. Okay, this is the first one. Number two, 1 over square root 3 is 1.73 something 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 something. Okay, no, hang on. This is 0.577. The other side, which is square root 3. Okay, the fractions, the surd itself, I'll show you later. But let me show you square root 3 over 2 first. Square root 3 over 2 is 0.866. Do you see this very familiar? Just now in the previous example, we got a question that is 0.866 something something something. In fact, that fraction is exactly root 3 over 2. Okay, then we got square root 2 and square root 3. Square root 2 is 1.414. And square root 3 is 1.73 something something something. You don't have to know anything more than these decimal places. I know that there's a whole bunch of numbers at the back. Okay, please don't waste your time going and understanding the 100 decimal places of this, like how some people memorize the 100 values of pi to test their memory. Okay, if you want to test your memory, then go ahead lah. Okay, but in this context, we are just looking at the most crucial values to identify these special surds and fractions. Okay, so these values are things that you always see. Okay, if you can go ahead and press the calculator, press the calculator for these values, and then you see that it's actually these values. So familiarize yourself with them. Very important. Okay, so now how do we use this to relate to questions that will ask you about special angles, and then they ask you about certain lengths? Remember what they will ask you. They will only give you length of two sides and find the angle, or they give you one angle, find the other length. That's all they will test you. But with this itself, there's a lot of things that you can play around with. Let me show you how. Okay, I'm going to recreate the triangles over here so that y'all can actually see. Okay, you see, this is how I create my special triangles. Once I key in these numbers, right, all the values will be out immediately. All of this will immediately show itself. Okay, so if I use a very classic example, okay, example 1. This is the most typical one. Okay, find the question mark, find the unknown, or maybe they call it X lah. They call it X lah, Y lah, whatever lah, don't care. Okay, find X. Okay, so obviously from here we identify that this triangle is an isosceles triangle. Do you see that actually it coincides with the one with the 45? So it's automatically known that this angle is 45 without a question. This is definitely 45. And instead of going straight into, oh, because we learned about formula, ma. Okay, so and then this is a sine. So okay, sine 45 equals to x over 3 over 2, blah, blah, blah. Then solve. Yes, this is correct. Okay. Yes, it can be done. However, there's faster ways to do it. Okay. This is what I want you all to learn, which is to see the ratio. Understand the base form of the triangle. Understand the base form of the triangle, and you can immediately see the answer for the unknown. Look carefully over here. If I were to zoom in on the base form, if I just extract out the base form, this is not a good triangle. Yeah, okay. What we have learned in the base form of the isosceles triangle is 1, 1, square root 2. So if today they give me 3 square root 2, remember I mentioned about the ratios being the same all the time. We compare the square root 2 here and the 3 square root 2 here. How many times difference? It is 3 times difference. So if the hypotenuse is 3 times larger, this unknown length will be 3 times larger as well. It will never change because it is a proportion. Therefore, x is 3. So even if today you press 3 square root 2 times sine 45 to get x, you will get 3 as well. You will get 3 as well. You do not need to key in the calculator for this anymore. Okay, you do not need to key in the calculator for this anymore because there is no point in doing so. And they will not give you any bonus marks if you solve it that way. On the other hand, if you do it wrongly, you shift your fractions wrongly, you'll be penalized instead. Okay, so straight away, look at the ratios. It's 3 and it is 3. That's all. Okay, don't change anything else. Don't change anything else. That is all. This is the most classic example. Okay, let's try one more. Okay, let's say I have another triangle that looks like why they all give me isosceles? I don't want isosceles. Okay, it's good. Okay, so maybe they give me this is 10, for example. Find this. Okay, this is slightly more different, but it is still the same thing, guys. It is still the same thing. Okay, you see that now we are given theta is 30, we are given opposite is 10. We need to find the adjacent. So from here, let's recall back on the base form of the triangle. See, if I were to retrieve it again, this is 30. If I recall my base form, I'll be writing these numbers already. Straight away. So from here, if I were to compare the triangles on its own, do you see that actually the 10 is in proportion with the 1 over here? Okay, because they read it on the same side, both of them are also the opposites of the angle theta, which is 30. So in this case, can I immediately see what is the value for this? Without a question, it is just 10 times of square root 3, which is 10 square root 3. Done. No more tangent 30 equals to 10 over question mark. Oh, so question mark equals to 10 over tangent 30, blah, blah, blah. And then the worst thing is when you key in the calculator, you don't even know what you're finding because the calculator will give you, oh, this is like, because root 3 is 1.73, so it's 17.3 something. Okay, so let me just key in the calculator and show you guys. Tangent 30 this. So you got 17.32, blah, 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 blah. Then you got lost. This decimal. I haven't known this decimal. What decimal is this? Then you yourself get confused. For what? Don't waste time. Straight away, see the proportion. See the proportion. It is 10 square root 3. That's it. That is your answer. If you are required to go and solve for this answer, at least you must have a very clear understanding that this is 10 square root 3 and not just any other random decimal that you got off the calculator. Very, very, very important. Okay, I've seen so many students got lost over and got confused over this thing because they don't know the values of the special angles and they are not familiar with it. Very unfortunate, and it's a waste to get yourself penalized over these kind of things. Oh, super waste. It's a super waste. So don't really don't get penalized for these kind of things lah. Okay. So this is very simple, but you must be very clear that it is a 10 square root 3 because you relate it with that base model of the triangle. I'm not talking about any other triangle. It's just 30, 60 and isosceles. That's all. Any other angles that you see, that is not in the 30, 45, 60 spectrum, it's something else really. That one is on a higher level. But we are only talking about special, in this case, we are talking about special angles here. So we will just stick to it. Okay? So with this in mind, there are so many things we can talk about. There are so many the numbers and combinations we can talk about. Because all of the numbers, right, must and can only follow these proportions, which is this proportion. It must follow this. It will not go wrong. That's why I advocate drawing the special triangles much more than anything else, because it will allow you to quickly see the special angles for all your other angles, for all your other lengths as well, all your other lengths, because the lengths must follow this proportion. So you just need to map. Okay. So for example, if today they are, if for example they don't give the 10. Okay, example, they don't give the 10. They really don't give the 10. So maybe I erase this 10 away. I'm gonna put something else. I'm gonna put like maybe I put a hypotenuse. Hypotenuse, maybe I go something bigger. Okay, I go something bigger. And it's a very ugly number. For example, 78 or 72, whatever. It doesn't matter. So they give me 72. Can I find the rest of the sides? Yes, I can. And I can find it immediately because it follows the exact same ratio. Okay, so that means if the hypotenuse is 72, and I learned over in the previous example that the opposite will always be half of it. So this must be 36. It is a must. Okay, and then over here at the adjacent, what is the adjacent? Don't need to find cosine 30 equal to something over 72. Don't need. Because I found that the opposite is 36. Therefore, the adjacent will definitely be 36 square root 3. Because it follows the same ratio. Do you see that? It follows the exact same ratio. It is the same ratio throughout, as long as the theta is 30 and 60. This triangle will always be in the same portion. Okay, so likewise for the previous example, if I have an isosceles triangle, I know that it's square root 1, square root 2. I already know this by heart already. Let's say I already know this very well. So imagine today I'm going to get something like, I draw another triangle, for example. I'm going to draw a bigger triangle, but it is still isosceles. Then I know, then the question tells me that, okay, maybe this one could be 30, for example. This is 30. So because it's isosceles, so my adjacent will also be 30 lor. Correct? So what will be a hypotenuse? Straight away. No need to see one. 30 square root 2. It's immediate. It's meant to be immediate. Okay? So, or even today they give you some sort of like weird decimals. Okay? Maybe they give you 1.5. You will still get it the same thing. You get the same thing. Okay? And how, and can I actually prove this? Yes, we can. Because okay, according to Pythagoras theorem, how do we know that it's 1 and square root 2? It's definitely there. Because we know that the hypotenuse square is equals to the opposite square plus the adjacent square. This is what we have learned in secondary 2 where we talk about Pythagoras theorem, a square plus b square equals c square. So I just change the ABC to my hypotenuse opposite adjacent, same thing. So same thing also, this is 1 square, this is 1 square. So hypotenuse square is a 2, right? So 2 equals to 1 square plus 1 square. So what's my hypotenuse? Square root 2. That's how it works. That's exactly how it works. Okay? This is just like a special case of Pythagoras theorem where we have one, if the two lengths are the same, then this ratio will happen. That means if the two lengths are of the same number, like that means in a case of an isosceles triangle, the hypotenuse will always be square root 2 times of the sides. It is always the case. Just that we got a small solid understanding here. Okay? Okay, so this will be for the special angles. Just remember, it's always in the same proportion. Always in the same proportion. Okay? I'm going to erase off this Pythagoras proof. I don't need to prove anything. Now that you guys can actually see. So all you need to remember is 1 root 2, 2 1 square root 3. 1 1 root 2, 2 1 square root 3. See? 1 1. So how I remember it? I remember it is 1 1 square root 2, 2 square root 3. Super easy. Or I can say 1 1 square root 2, 1 2 square root 3. Whichever way that helps you remember it. But as long as this triangle is out, you can relate it much more, I would say much more conveniently, much more visually to your questions that you're looking for. Okay? Okay, so now we are kind of done with trigonometric ratios, and no, not just ratios, but the special angles. Okay, and finding the basic angles and all. We also look into what else? Trigonometry of supplementary and complementary angles. This one. A lot of people ask me, hey, how to remember? I know it's being taught. You guys are required to go and like understand what it meant. Okay. Personally, I would say don't freak out over this lah. Okay. This is the third part of complementary and supplementary angles. Okay. Take a 5-minute break. 我要吃东西。Okay, if you guys got any questions, can just ask. It's quite interesting. Now there are still the Discord server is still actively asking for help. So you just tag the whole, you see, as you can see on the right hand side of the screen, for those people who are on Discord. The way the things you're asking is like really out of the world, man. But some of them I can solve, but not all. Some of them are quite simple stuff. For example, this is a very good one. Determine the length of K the nearest centimeter. Okay, so this one requires more things, sine rule, all these things. Has your question been solved? Their system is so good. Really, really, so good, so good. But I don't think I'll reach to that level. Lah. This is like international, this one crazy, isn't it? Okay, let's move on from here. Eating my bun. It's not a bun, custard.
It's a puff.
Custard puff. Okay, got it.
You just put it.
No, don't drop it. You didn't say anything.
Sauce and pepper. Mhm.
Okay. So in this case, in case you all really forget what is complementary angle, what is supplementary angle. Okay, guys, just go back to primary school and go and see. This one learn in primary school already. Oh, computer low battery. Shit. Hang on. Okay, it's up. Okay. To help you all recap what is complementary, what is supplementary. This one okay, let's do a quick recap. Complementary. What is complementary? Guys. Complementary means add up to be 90 degrees. That means I angle A, I angle B. So angle A plus B is 90. So I can see that angle A and B are complementary angle. Not paid angles, complementary angles. I know they are like free, but they're not free, whatever. Yeah, but yeah, they add up to be 90 degrees. They're called complementary angles. Okay. Next one, supplementary. Angle C plus D is how many? 180. So we say that angle C and angle D are supplementary angles. For those of you who don't know what is supplementary and complementary, this one for you. Okay, you want to take screenshot, you want to take whatever, let me know. Just go and take. Okay. So now that we understand this one already, how do we understand? How do we help ourselves to find the relative angles for the things? Okay, so these are your complementary angles. And then I have my okay, so these are the two things I'm talking about. Okay. So what is the approach? Okay, let's continue. Trigonometry of complementary and supplementary angles. How do you go about doing this? Okay. That means right, for example, they give you the value of maybe sine whatever, man. Maybe they give you sine 22. They ask you to find sine 28. Sine 68. Okay. So maybe they say that okay, sine 68 equals to x. Example, I don't need to know what x is. I just need to know that it's represented by sine 68. find sine 22. So you must go and see what is the relationship between 68 and 22. You see that both of them are which one? Complementary or supplementary? Complementary, right? So that means if I know that sine 90 is x, I need to find what is sine 90 minus theta. Okay. So in fact, for this one, I really don't have any trick to it. There's literally no trick to it, because you just need to go and draw it out and find the other side. Okay. But of course, there's a way. Don't say no way, just have to draw out. But we need to understand that we need to draw it out on the triangle. Then you see how does it relate with the other side. Okay. Okay. So, for example, what's happening over here is, given that sine 68 is x, so let's say this is 68. Okay. And according to our question, we are given that sine 68 is x over 1. Remember what we have talked about at the very beginning, where it's actually this x is actually a ratio, it's a fraction. So if we just give a whole number, it's just over 1. Okay, so don't be confused by, oh, is that where? It is the same thing. Okay, so sine is what we recap is opposite over hypotenuse. Opposite over hypotenuse. What does it mean? Opposite over hypotenuse. So x over 1. This is what it means. Okay, opposite over hypotenuse. Just repeat, opposite over hypotenuse. So x over 1. Because x is just x over 1, because I think by now you all should know that. Okay, so that means I want to find sine 22, which is over here. So that means, right, sine 22, if I change it over here, now that means I need to find the opposite of 22. Right, this length that I bracket over here, I need to find this one first. So is there a way I can find this out? Yes, I can, because this question mark is actually equals to 1 square minus x square over square root, like that. Okay, so in case 1 square is just 1, so I can remove the 1. So the question mark is actually square root of 1 minus x square. So what is sine of 22? 1 over square root 1 minus x square. That's what it means. Okay. I'll just lump it all together and share, because normally you all will learn about supplementary angles first before you learn about complementary. But today I'll just put everything together, because there's, by O levels, you all should know everything. Okay, so this is how it works. Okay, this is the first example. Second example. Given that cosine 61 is A, you can give any letter, A, B, X, Y, whatever. Find tangent 61. Okay, maybe again, shall not terrorize you a bit. Find cosine of the 90 minus 61 should be 90 minus 61 should be 29. Okay. Oh, my Zoom got hang out again. Yes. The Wi-Fi not stable. Okay, I'm back. Huh. Oh, thunderstorms out there. But it shouldn't affect Wi-Fi here, what? What is? Okay, back here. Okay, so given that cosine 61 is A or alpha, whatever, okay, find cosine 29. Same thing. They both of them relate by the complementary angle. So same thing. The best way to do this is to really draw a triangle and see for yourself. Now it's A ma, you see, same thing, cosine 61, A over 1, A over 1. So A over 1. Okay, so how do you find the long side? It is still the same because I want to find this question mark. The question mark is still 1 minus alpha squared. So cosine 29 will still be 1. The cosine 29 will be over here. Oh, sorry. 29 over here. So I want to find cosine. That means it will be 1 minus alpha squared over, technically it's over 1 lah, but I don't divide the over 1 lah, just like that. Okay, I think it's lagging a bit. Okay, so basically that is what it means. So basically, give it according to what is given. Just plot it back into the triangle and go and see what does it actually mean. Okay, shouldn't be too difficult for this. Okay. So same thing for tangent, work it out the same way. Okay. Tangent. Do I need to give an example of tangent? Don't need. Okay, I'll move on. Okay, now we are done. We're kind of like done with complementary angles. Now I want to move on into supplementary angles. This one quite interesting because this allows us, right, to actually tap into angles, right, that is beyond 90 degrees. Because in our previous example, so all the way from the start until now, right, we are talking about angles within the right angle, maximum 90 degrees, right? But using these supplementary angles, right, we are able to tap into things like 135. We are going to tap into things like 120. We're going to tap into things like 130. It means all your obtuse angles, will require this supplementary angles, trigonometry of supplementary angles. Okay, so how do we help ourselves to understand this? Okay, so don't get freaked out. Really, don't get freaked out because how we do it over here. The most simplest and the most clear-cut way is to test it with your calculator. Okay, test with calculator. There's no simpler way to do so. Okay, you can memorize, yes, but I feel right now there's no need to memorize. Really, there's no need to memorize. Just as long as you know that every time you want to use it, go and test the calculator. If sine 60 is something, so what is sine 120? Oh, it's actually the same value. Therefore, sine 180 minus theta is equal to sine theta. Let's look at this also. Cosine 50, for example, cosine 50 is 0.64. So what's cosine 130? Okay, so cosine 130. Oh, it's the negative of this value. So therefore, like this. There's really no trick to it. It's really no trick to it. And tangent, same thing. Tangent 80, for example. Tangent 80 is 5.67 something. I don't really care. Then I go and press tangent 100. Oh, it's the negative value. That's all. That's all. Okay. So of course, it's convenient for us to remember lah. But I feel that right now you can just immediately key in a value, test the values. That means you key in a certain acute angle, then you key in for the corresponding supplementary angle. Then you go and see what is the relationship between the results. The numerical value itself doesn't matter unless it's required in the question. But we need to understand that actually it's the same value. Actually it's a negative value. But as we see from here, it's actually pretty straightforward. Okay, that means the sine of 180, sine of the supplementary angle is equal to sine of the angle. Otherwise, it's negative. Okay, at this point of time, you don't need to know why. This is why you need to learn the trigonometric curves and all that stuff, but we leave that to next time. In fact, last week, I did talk a bit about these trigonometric curves, about sine curve, cosine curve, all these things. But I talked about it last week. Maybe a few weeks down the road, I'm going to talk about it again. If you guys want it, then we can do it again. Otherwise, it's fine. Then we can just leave it like that. Okay, all clear, quite okay with this. Okay, so complementary angles, that is all. That means complementary angles, supplementary angles. Very, very simple applications. There's really nothing fanciful about it up to this point. Okay, at this point, we need to look at the other things already. This is the key part. This is the most interesting part, which is to evaluate other angles that's not mentioned at all. Okay, and they don't give you any values. Okay, this is the most rare type of questions, but they will still ask. So for example, I came across this question across the social media. Evaluate sine 15 without using a calculator. And even if you press calculator for sine 15, you'll get a whole bunch of decimals. You cannot get the exact value. But now the question tells you, find the exact value of sine 15. They're like, wow, what is this, man? Okay. Then you realize, right, there is no special angles because our special angles is what? 30, 45, 60, 90. Okay, at zero. We learn these 5, and we know the special properties of these 5. And we know that the supplementary of these angles. We know the complementary of these angles. But sine 15 doesn't fit into any of these numbers. Then they tell you, find the exact value. This one very anal. They ask you find the exact value of sine 15. So here's the thing. We need to understand the addition. So how do we solve this question? We need to introduce this thing called the addition and subtraction formula. You see, even addition and subtraction also got formula one. Okay, and it's for all sine, cosine, and tangent. It's crazy. Okay, I'll quickly write it over here first. Thankfully, you do not need to memorize it, but you need to know that it is being provided in the formula sheet. It is being provided in formula sheet. Okay, so what is the addition and subtraction formula all about? Okay, it looks like this. Sine A plus minus B is equals to sine A cosine B plus minus sine A cosine A sine B. This is the first one. Okay, I'll remove these special values first. I will put it by the side. We will use it later on. 30, 45, 60, 90. Okay, so sine A plus B is sine A cosine B, cosine A sine B. Then cosine A plus minus B will be cosine A cosine B minus plus, you see, is the sign changes, minus plus sine A sine B. Okay, tangent A plus B. Guess what? I also don't remember. IDK. I'm going to just write IDK here because technically I know that there is such a formula, but I don't even bother memorizing it. I just when the time comes, I just going to take it out and just plunge the numbers in. That's all. Okay. But in any case, let me go and verify that my addition formula is correct. Okay, I'm just going to quickly search it up and ensure that it's correct. Okay, cosine A cosine B plus cosine A sine B, correct. Sine A cosine B Sine A, sine B. Okay, yes, my formula is correct. Okay, good. So tangent, tangent according to here, okay, I can just point it to you. It's actually 2 tangent alpha. No, that's for tangent. Oh, yeah, here. So tangent A plus B, where is it? Okay, so tangent A plus minus B is equal to tangent A plus minus tangent B over 1 minus plus tangent A tangent B. To be very honest, I really don't remember this formula, but I know that it's provided in formula sheet. Okay, the more often used ones are your sine and cosines. Okay, okay. So from here, how can we use this addition and subtraction formula into this very weird value of 15? Okay, we already know the special numbers 0, 30, 45, 60, 90. So now the key point is we need to see how do we get 15 as a result of either you plus or you minus any two of these special numbers. I say again, this weird number here, I need to go and see at what case, which of these two special numbers over here, either you add them or you subtract them, will allow me to get the number that I'm looking for. So as you can see from here, there's actually a couple of them that I can try. Because let's lay down the formula here. Sine 15. Can I say it's actually sine 45 minus 30? Yes, I can. Can I also say it's actually sine 60 minus 45? I can also do that too. There's more than one way to do it. Okay, but the most important thing is you must understand that this number that we're looking for comes from a result of either the sum or the difference of two of these special numbers. Okay, can so from here I can even go out and find 105, for example, sine 105, because I know sine 105 is made of 60. It's a sum of 60 and 45. So I can also find the value of sine 105, for example, for using the addition subtraction formula. Let's try it out later on. But let's try sine 15 first. So from here, let's use the basic one, sine 45 minus sine 30. Let's apply this formula into the question. Okay, so this is also where I find keying it in the calculator and getting the decimals and remembering how the decimals relate to special fractions works very well here. I have no time to go and draw out the table of values draw a special triangle blah blah blah. I got no time for that. But immediately from the calculator, I must know exactly what is the fraction. Okay, I'm going to show you guys here. So now from here, I'm looking at sine 45 minus 30. So essentially, we are focusing on this formula, the first one. The first one is what we are looking for. So from here is sine A minus B. My A is 45. Okay, remember, I'm just going to write it here. A is 45 and B is 30. So this is what we are looking for. That means when I sub in the values, A is 45, B is 30. Okay, so before I go into the special values or numbers, I put it in the formula first. Put it properly in the formula first. Okay, so I'm going to get is sine 45 cosine 30 minus cosine 45 sine 30. Okay, and also from here, I have no time to go and remember all. Like I said, I don't remember my special values all here. Everything comes from the calculator. So I must see, okay, sine 45 is 1 over square root 2. because it's if you can take out a calculator and do it right now with me, sine 45 is 0.707, so it's 1 over square root 2. Okay, cosine 30 is 0.866, so it's square root 3 over 2. So you see that I can relate the numbers very quickly. Okay, that is a skill, important skill. Cosine 45 is also 1 over square root 2. Okay, sine 30 is half. There's no, if I were to write it in like decimals, 0.88 times 0.88 times 8.866 times 0.707, it has no meaning at all. It has no meaning at all because there's nothing I can do with it. But if I put it in fractions, I can do something about it. See over here? Okay, so from here, how do we do it? So from here, all I need to do is to make this a single fraction in the simplest form. From here on, is testing on your certs. Okay, for those of you who are not sure about certs, go and recap about certs first. Okay, then you come back to this. Okay, so from here, what do we actually do? From here, we can take out the 1 over square root 2 as a common factor. Okay, so it's square root 2 minus half. Okay, and then from here, I want to change my 1 over square root 2 to be a proper rationalized denominator. So it's actually square root 2 over 2. Then I evaluate what's inside. So it's actually another half square root 3 minus 1. Okay, so from here, can I continue on this? I can. So it's square root 2 over 4 times square root 3 minus 1. Okay, so from here, same thing. Can I continue? Yes, I can continue. Square root 6 over 4 minus square root 2 over 4. Then from here, I can combine them together because it's square root 6 minus square root 2 over 4. That's my answer. It looks, the answer may be very ugly, like this in the third form, but it's not as ugly as a bunch of weird, foreign, alien-looking decimals. Of course, if you key in a calculator, will I get a value? Yes, I can. It's technically about 0.258819, blah, 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 but really, this number makes no significant meaning. What I'm looking for is the exact value because it says find the exact value. That means I don't want, if they say find the approximate value, I just key in calculator, I round all my answer to three significant figures, then I'm done for the day. Then why do all this stuff? Why not? I'm looking for the exact value. That means it must be left in a proper cert form, which is like that. Okay, so this is for sine 15. Okay, it's just a very simple application of the subtraction formula in this case. Okay, let's try one with the addition formula. Okay, so in this case, question 2. Find the value of cosine 105. Okay, cosine 105. Okay, so same thing. Cosine 105 equals to cosine 60 plus 45. Because same thing, I want my number to be either a sum or a difference of two of the special numbers. In this case, 60 and 45. And do a recap of my formula. What does it mean? This is a cosine A, cosine B minus sine A, sine B. So cosine A, cosine B minus sine A, sine B. Just like that. Same thing. I'm going to go into my calculator and straight away, using the numbers that I get, I'm going to key in the fractions straight away. So cosine 45 is 1 over square root 2. Okay. And then I have sine, what else? This is like sine 60, right? Sine 60 square root 3 over 2. And then I have sine 45, which is 1 over square root 2. Okay, so do you see that actually we are getting the same answer as sine 15? Wow. Interesting. Do you see that actually we will get the same value? Wait, no. Is it same value? No, not really. Just now is A plus B, now is A minus, now it's inverted. Okay. Interesting. Because right now what I'm observing is this one and this one. Do you see that actually they share the same terms as well? Let me check again if they are the same terms. 1 over square root 2 root 3 over 2. 1 over square root 2 root 3 over 2. 1 over square root 2 half. Oh, good. It's exactly the same. So building on that one. Oh, this is not a very good example. Can I actually say this? So this term, this whole bracket term over here, right, is exactly what we have did over here. Exactly the same thing. My goodness. Yes, it's exactly the same thing. Therefore, this answer will be negative of this answer, which is, if I were to do it again, how I do that? It means it's square root 2, 6 over 4. Wow. Yeah. Amazing, isn't it? Because technically, it is actually minus of this value. So what we are doing now is I'm just going to invert the terms inside. Interesting, right? So now we have come up with a conclusion. Cosine 105 is actually equal to sine 15 by the negative of it. So what happens? Like I said, is this a property that needs to be memorized? No. Okay, please don't go and memorize all the different angle or the combinations. You have no time for that. Okay. And unlikely they will ask you them consecutively. But even if they ask you consecutively, for example, part A, they ask you sine 15. Then part B, because of sine 15, once you have found sine 15, right? Hence, evaluate cosine 105. They will ask you to do a hence. They will not ask you to solve it from scratch all over again. It's impossible. So you must be like what we did here. We must be able to relate what we did in the green fractions and compare it over here with this part. And then we realize that, hey, it's actually the same thing. What? Means it's not a good example. I wanted to show you like a way that we can do like the addition formula. Okay? Maybe something we can do differently is a tangent. Tangent 75. Can I do tangent 75? Yeah, tangent 105. Tangent 105. Okay, tangent 105 is equals to tangent of 60 plus 45. So in this case, my A is 60, my B is 5. So same thing. Put it into the formula. You see, I also need to go constantly look back at the formula. It doesn't matter. You can always refer to the formula. So tangent A plus tangent B. Okay, minus 1 minus tangent A tangent B. Okay, so from here, same thing. Key in calculator. Tangent 60 is root 3. Tangent 45 is 1. Over 1 minus tangent 60 is root 3. And then tangent 45 is 1. So what we are looking at here is actually 1 plus square root 3 over 1 minus square root 3. So from here, how to solve? This one, rationalize your denominators. That means I multiply by 1 plus square root 3 and 1 plus square root 3. Then I will make the denominator 1 minus 3. And then what's on the top? On the top will be 1 plus square root 3, the whole thing square. So if I will expand this, same thing, 1 plus 2 square root 3. If you don't know this by now, you should go back to lower sec. This one is the algebra identities. Okay, don't freak out if you see a cert. It's the same thing. Okay, then plus 3 over this is minus 2. 1 minus 3 is minus 2. So 3 plus 1, 4. 4 plus 2 square root 3 over minus 2. So you can see that actually there's a 2 common factor I can strike it off. So it's actually 2 plus square root 3 over minus 1, which is, if I were to turn things around, it's actually minus 2, minus 2 minus square root 3. This one answer. That will be the answer for tangent 105. It's okay to leave it in such an answer because it's already my denominator is 1 technically. So yeah, so be it. Okay, but what we are focusing on here is the application of the formula. Okay, like I mentioned, these formulas are provided to you in your formula sheet. So go and use them, plug in the numbers one by one, see it for yourself, and understand what the decimals mean on your calculator and put it in, and then you can solve for it immediately. Okay, at this point of time, it is useless for you to press calculator. Some people say they don't know how to do 1 plus root 3 equals to, then they key in calculator 2.73 blah 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 blah. Then 1 minus square root 3 is negative 0.73 blah 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 blah. Please don't do that, guys. The decimals makes no sense. And then you will be confused by your own confusion. Then you will be even more confused. So don't do that. When we are talking about trigonometry and special angles and blah blah blah, all of these are definitely in fractions. It's either in fractions or in surds. It's never in decimals, unless the final answer requires so. So maybe for this one, I go and key now. So it's a minus 2 minus square root 3. So I get this very ugly answer called negative 3.73205, blah blah blah. So it's negative 3.73236. So really, there is the decimal only appeared at the very end. From top to bottom, I did not do any decimals at all. It's everything properly in surds. Then I convert it to a decimal because the question wants me to put in decimal. That is all. There's no point for me to put it in the decimal in the working step because it will confuse you even further. So what if you get 2 plus square root 3? So what if you get 1 plus square root 3, which is 2.73, then whole thing square? Then you get like I don't know, 5.29 something, or 5.27 square is about 7.29 something. What's the point? It has no value at all. 7.46 something. For what? It does not serve any purpose. Okay, so always work in surds and fractions. So that is why your surds must be good. Okay, for those of you who don't know what surds is, it's a Sec 3. It's an AMAX topic actually, but it's actually also covered in EMAX. But it's being talked about more closely in AMAX. Okay, so of course the trigonometry spans over EMAX and AMAX, but only AMAX are talk about these kind of special angles. So Sec 4, Sec 3 AMAX, right, we'll talk about surds. Then they will talk about this. So if you want to do this well, go and understand your surds first. All your square roots are, how do you rationalize the denominator? For example, just now in the previous question, I very conveniently changed 1 over square root 2 straight away to a square root 2 over 2. Why is this so? How does it work? How did it change from here to here? And then, for example, if I take square root 2 times square root 3 is actually goes to square root 6. Why is it so? How does it work? If you are still very blur about this surds thing, go and recap surds first. Don't come here first. Stay out of this area first. Okay? Can Okay. I've covered all the things that I need to cover as of now for trigonometry identities. Trigonometry identities, then actually there's more lah. There's a sine rule, cosine rule. But that's more like applications. All right. Identities where you have to got to prove stuff. Like for example, like for example, your sine square plus cosine square is 1, then secant square plus 1 equal tangent square, all that stuff. But that one, you all want me to go through? I don't know. Want or not? Don't want lah. Don't want, then I'm going to go to other topics already because I've spent quite a bit of time into my the trigonometry already. So unless you all want to talk about other parts of trigonometry, then I'll just head on to other topics already. Okay, cover quite a lot of big views already. Then maybe next week I will continue on identities, double angle formula, then differentiate, integration. That comes after that because I know that now it's still in the term 2. Term 2, some of you might have not learned the trigonometry, the calculus of trigonometry. Maybe you haven't learned yet, especially for Sec 3 students. Maybe you haven't learned yet, so might be foreign to you. Okay. Okay, can. Okay, so for now, trigonometry is more or less done. I want to go back to a bit of Sec 1 topics. Okay, suddenly for Sec 4 becomes Sec 1, right? Okay, like I said, this quickfire is for people of all levels. So I try to cover a bit of Emax, a bit of Amax, then a bit of lower Sec Max as well. So I try my best to cover as much things as I can. Unless you have specific topics, you let me know. Okay. Previously, in the previous quickfires, I've talked about proportion. I've talked about the direct and inverse proportion. I've talked about percentage change. Also talk about the maps and skills. And then proportion, algebra. You want me to talk about algebra? Why you want me to go through fraction word problem? Go through primary 6 fraction word problem. I don't know. Not say cannot. Okay. Because technically, this is mainly for secondary school students, but primary schools are welcome to come in, but circle have lah, because they only learn pi r square, circles volume can. So requested to do volumes of solids, area and volume of solids. Yes, thanks for the request. This is actually quite good. Good topic. Okay, volume of solids. Of course, we're talking about area also. Area also. Volume and surface area. Surface area and volume of solids. Okay. So first of all, we must understand. Okay, 10% battery left, 20 minutes more. Okay, can switch between my charger. Okay, volume of solids and surface area of solids. A lot of people struggle in this kind of topic because number one, they are not a few reasons. Number one, they are not they haven't fully mastered the concept of area yet. Finding the area. And number two, they are not exposed to the different types of solids there are there. Okay, then they find it they find the transition from area to a volume very abstract. This is the reason, the main two reasons why people struggle. Okay, so and then of course, you must understand all the different types of surfaces and their respective areas. Then we can go and find a surface area and subsequently the volume. Okay, because surface area is just like for example, I'm given a solid. I just putting the two types of area together, two types of the surfaces together to make a surface to come together and make a surface area of an entire solid. 我那个 iPhone 的 wire 丢 Okay, my stream is dying also already, so I need some emergency power. Okay, so if y'all can y'all recap on your surface area and the volume? Because I have to go back a long way there if you all have to go start from basics. Okay, you got things like your rectangle lah, square lah, circle lah, semicircle. Yeah, not an oval. Oval is JC stuff already. Got oval, JC. That one is a parabola already. Bye bye. That one A level. Then you got the semicircle. Got quadrant. Okay, then from here we can extend it further to what? Our trapezium. Then we find what? Parallelogram. Essentially, this is what is being tested and this is what is being taught lah. So you guys will be able to you will find yourself familiar with these kind of things. Okay, so I draw a parallelogram here. So before we even talk about the volume and surface area, you guys must be able to recognize these shapes at the very beginning, at the very least. Okay. Area lah, we talk about area, just the area. Because this area of these plane figures will allow us to find the area of the surface area or even the volume. Okay, so let's go through. Oh yeah, triangle. So it can be like this, can be like this, can be a scaling triangle. Okay, let me try this. Yeah. So I have like that. I have like that. I have this one. Like this. Isosceles. So I have about 1, 2, 3, 4, 5, 6, 11 figures here. But in fact, some of them, the formulas are actually quite related lah. So there's no need for you to remember 11 distinct formulas, but you should understand that they should all be related. Okay. Okay, so to help us find the area, I just focus on the area now. Area, this one is easy, right? This is base times height. Okay, this is the length square. So this is the base, right? So it's base square. Okay. Then for circles, if I have a r, okay, then it'll be pi r square. Then from here, I can divide the rest of my things really. For semicircle, it'll be half pi r square. Then my quadrant will be 1/4 pi r square. Okay. Triangle is super easy, half times base times height. Okay, so same thing. This one for a quadrilateral or equilateral triangle, it is still half times base times height. Okay, now that we know about the trigonometry stuff, can we actually do a bit more extension to this, actually we can, but I shall not do it here. Because this one is, remember just now we talked about trigonometric special triangles, this thing appeared. Okay, for those of you who are listening. Same thing for this one, half time based on height. You see, everything is the same, nothing fanciful. Okay, this one, half time based on height. Nothing fanciful. All the same. So I'm going to just put everything together and call it this base, this height. So it's all half time based on height. Okay. Then from here, I'm also looking at my parallelograms as well. So same thing, base, height. So this is base times height. Then this trapezium slightly more interesting. I got A, I got a B, then I got a H. So it's half times H times A plus B. Okay, so I'm going to circle them. Yeah, so these are my areas that I need to understand first before I go into the surface area and volume of solids. Okay. So people are asking why is it that I must understand these areas formulas first before I go into volumes? The reason is very simple. The reason is because the subsequent solids that you all see, right, is just stacks of these figures. Give an example. What are the kind of solids that you all see? Okay, so maybe you all have something, the most easier one, cube. Okay, then you all have a cuboid. Okay, my cuboid looks damn ugly, but it's still a cuboid. Okay, then I also have what? Cylinders. Okay, and with a cylinder, I can have a semi-cylinder. I have also a quadrant cylinder. It's all the same. Can I also have things like my triangular prisms? Do you see that actually they are all the same thing? So let's say if I draw a triangular prism may look like this. Okay, so these are just some of the common figures and solids that you all see. Okay, there are definitely much more. But what is one thing in common? They are all uniform. This is very important. Uniform. So what does uniform means? Uniform means, right, from one end to the other end, right, it is all the same base shape never changes. The base shape never changes. If you look at a cube, it's just a square, but it's a layer of squares. Can you see that? It's a layer of squares. Then I look at the rectangle. It can be a rectangle, it can be a stack of rectangles, or it can be a stack of squares. Right? So it's like, for example, if I were to pack, I don't know whether you guys even know what a CD is. Do they even know what a compact disc is? Like a CD? They only know thumb drives, right? And Spotify, right? You don't even know what CD is, right? YouTube, right? Okay. If you guys know what a CD is, then yeah, really you guys know what a CD is? No lah, oh, they know, they don't know. CD algebra letters. Wow, jialat lah, this one. Okay, I need to find another example. Okay, for example, you have a stack of test papers. Okay, a stack of test papers is just like, you see the base shape is a rectangle shape. Okay, for example, I have a stack of exam papers. Then I'm going to keep stacking them. Then keep stacking them. And then it will go up and up and up. Okay, so I'm bad at sketching this, but I'm gonna try. Don't laugh. Come on. Should work lah, can lah. Okay, so this is the base shape. So as I continuously stack test papers, other test papers, other test papers. So I'll get like this. So what happened to my drawing?
The cheese fell from the sky.
And here.
The cheese fell from the sky.
Stop it,
into a toast.
So you can see it's like it's like test papers after test papers being stacked on top of each other to form a rectangular cuboid. Okay. So as you can see, if we were to find the surface area of one rectangle, which is the area of one rectangle, I'll be able to find the volume of the entire thing. Because why? It's only that same surface area but duplicated by h times, which is the height. Therefore, for the volume of cylinder or prism or cube or cuboid, okay, they may have each of their own formulas, but it's always the uniform cross-sectional area multiplied by height. This is the very, very important concept to understand. You may remember the formulas in its own, okay, length times breadth times height, length times breadth times height, then whatever, half BH times height. But if you don't understand the concept, you will not be able to link all of them together. That is very, very important. Okay, so if you are able to understand the concept of all of these things, right, you are able to string all of the formulas together. That is the most important thing. You string all of them together. So whether you are given a prism, it is the area of a triangle times the height. You are given a cube, area of the square times the height. Area of the cuboid, area of the square times the height. Cylinder, the circle area of circle times the height. It is the same thing. It is exactly the same thing. Okay? Or even you are given some oddball figures, if they say uniform cylinder, uniform solid, means you can find the cross-sectional area, then you find the height. It is always that case. Okay? Everything will come back to this concept. Okay? So that's why we have the volume of solids. Okay, even if they give you a trapezium, then they ask you to find the solid itself. Are you able to find the solid itself? Yes, you can, because it is still the same thing. Okay. So I'm going to attempt trying to draw again. So for example, you see a gold bar. So okay lah, decent lah. This one. Don't grade me for this, please. Don't laugh, come on. It's good. Okay, so you are given, like, for example, you are given a chocolate bar or a gold bar. They look like this. And then you're supposed to find the volume. Okay, don't freak out. There's nothing to freak out. Because ultimately, it's just a layers and layers, stacks and stacks of trapezium. Stacks and stacks of trapezium. So you just need to find the area of one trapezium. Then you multiply by the height lah. Correct or not? So for example, this is A, same thing. This is B. This is still the vertical height. And then we have like the length over here. So how do you find this one? Same thing. Half times height times A plus B times the length. It's going to be the same thing already. because we always understand that this is actually uniform cross-sectional area multiplied by the height or the length, depending whether you are lying the solid down or you're putting it upright. Next one. If you lie it down, means it's the length. If you put it upright, it means it's the height. It's no difference. It's no difference. So it's actually essentially the same thing all together. Okay, so this is how the essentially the basis of volumes. The basis of volumes. Of course, right now we are also being introduced to other types of volumes like what? Like cones. Okay, like cones, or maybe we have like the what else? We have the pyramids. So you are given either a square base or rectangular base, then you have the tip on the top. So you are supposed to, in a way, find the volume of this one. Essentially, this is still the same thing, because instead of, it's just 1/3 pi r square h and 1/3 times base area times height. It's essentially the same thing. 1/3 pi r square h, 1/3 base area. You see, the base area is circle, that's why pi r square. This is base area of the, whether it's a rectangle or square or whatever. It is the same. It is always the same. Whether for it to be some oddball quadrilateral that is coming up, it's going to be the same formula anyway. So always remember, it's always uniform cross-sectional area times the height. Don't remember it like 7 individual formulas in your head. You will go mad. All right, don't do that. Please don't do that. Okay, so for what else? I think it's about time already. So I just quickly wrap this up. So for the volume, this is what we have. For surface area, it's really very subjective really, because we are looking at the individual solids over here. Then we got to find out the individual surfaces. And these surfaces are still rather easy, because if we were to open up and see the net of the figure, all of these are just made out of simple rectangles, squares, and circles. So you just need to open up and find how many, and to find the individual surfaces and add them together. That's all for surface area. Okay, the only thing that you need to take note is that you need to understand how many sides it is lah. Okay, that's the most basic things really. For example, a square and a cuboid has 6 sides. Okay, if you never ever see a cuboid before, there's something wrong lah. You must understand it has 6 sides. Like if you play dice, you'll know that it has 6 sides. Okay, then how about cylinder? How do you find a cylinder? Okay, cylinder is slightly more different, because technically it has only 3 sides. Because the third side, the 2 sides are the top and the bottom circles. Then the cylinder, the side, the bottle, the main material that covers the bottle, that's the third side. And it's one circular surface. So how do we visualize it? Just draw a line down. And imagine like you are taking a water bottle and you cut it down the middle line and open up. It's actually a triangle. It's actually a rectangle. It's a rectangle with the length h and the height h, and the length is the circumference of the circle, which is 2 pi r. So to find the cylinder, to find the surface area of cylinder, is essentially 2 pi r square, 2 pi r square, which accounts for the top and bottom cover, and 2 pi r h. 2 pi r square plus 2 pi r h. Okay, so if you remember it like 2 pi r square plus 2 pi r h in your head, you just directly put this in your head. It's very tedious because you have no idea why. But if you understand it from the individual components, it is very simple. Because it's the top cover and the bottom cover, that makes 2 circles, 2 pi r squared. Then we have the rectangle, which is length of 2 pi r, the circumference, times the h, which is the height. That's why you get 2 pi r squared plus 2 pi RH. Then you will know why. And sometimes they will trick you and say, oh, this cylinder is uncapped. Maybe no top cover. Then from this formula, you are able to edit and change accordingly. In that case, if I take out the top cover, the bottom cover still there, man. So it will be pi r squared plus 2 pi r h, no? Depending on what you're looking for. Okay? Then for surface area, unless you're talking about cones and your pyramids, because this one has this little slant height over here. It has a slant height over here. So how do you find a slant height? Just find it according to your Pythagoras theorem. You got your height of the cone, you got the radius of the cone, find L. Through what? Pythagoras theorem. So it's pi r squared plus pi rl. Okay, and then same thing for this one as well. Are we able to find the individual lengths as well? Of course we can. So if I were to do this, if we erase it, I want to find a slant height because I want to find the individual triangles. So technically, if I were to open it up, open the pyramid up like a flower, it will be like this. Where the rectangle is the base, and then the 4 triangles is the side. So essentially what I'm looking for is I need to find the vertical height of this triangle, which is essentially here. So same thing, how do I find it? You got a h, you got the length, you got half the length of the rectangle. Just Pythagoras, same thing. It is still Pythagoras. Okay? So of course, when the question comes, they will ask you a lot more things as compared to just looking for the volume and surface area. But the concept is the same throughout, because what we are looking at is how do we apply the formula. Once the formula is being applied, once the formula has been applied correctly, the rest is going to be 3 marks. Okay? So that's for volume and surface area. Of course, next week I can go further in depth about maybe sample questions to find the volume and surface area. But for now, we will just leave it as this first. Okay, so recap. So what we covered today, we covered a bit of trigo, about the basic sine, cosine, tangent, how to find them, how to understand them. Then the trick of special angles. How do we use the 2 special triangles to remember our 30, 45, 60, 90? And then we find the supplementary and complementary angles, which is 180 and 90. How does it work? And how do they relate to one another? Which is this one and this one. Okay, and also we went into solving weird numbers using either the addition formula or the subtraction formula to find the ratios of special, not so special angles like 15 or 105 or 75. All these can be solved already. Okay, and then a change of topic and a change of taste, we went on to the surface area and volume of solids. This one touched on a bit only, and for y'all to recap on the solids, the different types of plane surfaces, and how it will derive the volume and the surface areas. Maybe next week I will continue on from here and give you all some sample questions to do. Okay, so we have come to the end of the live stream. Discord, Zoom, YouTube, and my Telegram channels. So if you all have any questions, right, continue to interact with me on those channels to plunge in the questions. Okay, right now all the platform has been well established already. So go ahead and ask your questions over there. So if there's anything that you all want to clarify, or any certain topics or topics in specific that you all want me to go through in my platforms or my weekly chats over Zoom, you all can let me know. Okay, otherwise then we'll continue to interact with you guys through the articles and through the WhatsApp groups. Okay, so with that, we'll come to the end of the live stream. I'll see you all next week.